In this video, we'll be learning about Bronsted-Lowry acids and bases. Now, a Bronsted-Lowry acid is a proton donor, and a Bronsted-Lowry base is a proton acceptor. Now let's consider the following mechanism. Now in this mechanism, the base would be this B minus and the acid would be the HA. Remember that we said that the base would be the proton acceptor, and in this case the proton in question would be this H right here. So how will this base accept this proton right here? Well, in order for us to understand that and know that, we will be drawing the mechanism of how all this comes to be. Now, before I explain what the mechanism is, I want to state and make clear that the mechanism of proton, all of this will be occurring through a proton transfer reaction, and the mechanism of a proton transfer reaction involves electrons from this base deprotonating this acid right here. And we must also know that acids won't lose protons without the help of this base right here. Okay, so these electrons from the base will be making a bond with this proton from the acid. We know that hydrogen can only make one bond, and it's already making it with the B, as shown here in the product. Now, these electrons here will have to move back to the A, as shown here, and as a result, the A becomes negative. Now, all bases become a conjugate acid in the product, and all acids become or form a conjugate base in the products as well. Let's consider another example. Now let's draw the mechanism for this reaction. First of all, before drawing the mechanism, we must identify what our base and what our acid will be. In this scenario, our base would be this OH minus base, and this would be our acid. Now, based on that reasoning, we know that the base will be the proton. Recall, will be the proton in question, the proton acceptor, and the acid will be the proton donor. That means it will be losing this H. Now, in order for this to occur, these electrons from the oxygen will be bonding with this proton, and these electrons bonding the proton with the oxygen, in this case, will be moving back to the oxygen, as seen here in the products. So now, what will happen in the products? What will we see? Well, as stated earlier, this will now become a water, losing its negative charge, and this compound will be losing this H, as seen here, and gaining a negative charge due to the electrons that it gained during the mechanism. Okay, now what's next would be identifying the conjugate base and the conjugate acid of this reaction. The conjugate acid will be the H2O because this is the product of the base seen in this reaction. And the conjugate acid will be what the acid forms, what the acid becomes in the products. And the acid becomes the conjugate base. Now let's identify the mechanism by which this reaction comes to be. First of all, let's identify the base and the acid. In this case, the CH3O- would be the base, and the acid would be the water. So the water would be donating this proton, and the base would be accepting it. So this mechanism will occur by these electrons moving towards the hydrogen and forming a bond, and these electrons forming a bond between this oxygen and this hydrogen will be moving back to the oxygen, giving it a negative charge in the products, and this H will be having formed a bond in this compound in the products. Now let's identify what our conjugate acids and our conjugate bases are in this case. In this case, the conjugate base will be the OH-, because this is what is the product of the acid, and the conjugate acid will be this compound right here. Let's consider another mechanism. Now let's consider this reaction. In order to draw the mechanism, we must first identify what the base and what the acid is. And in this case, the base will be the OH-, and the acid will be this compound right here. So we know that the base will be accepting this proton and the acid will be losing this proton. How does this come to be? Well, these electrons move to the hydrogen and form a bond with it, therefore forming the following in the products, forming H2O right here. And these electrons in the bond between the oxygen and the hydrogen will be moving back to the oxygen, and this will be seen in the products as the following. We will see that our charge will be, our negative charge overall in the reaction will be conserved because this oxygen will have gained the electrons from the bond it used to have with the hydrogen, giving it an overall negative charge. Now let's identify our conjugate acid and our conjugate base. In this case, this acid will form a conjugate base in the products, and this base will form its conjugate acid in the products. Now let's do another example. Now in this reaction, this compound will be functioning as the base, and this compound will be functioning as the acid. So we know that this base will have to, that the electrons of this base will have to, now these electrons from the base will be forming a bond with a proton from the acid. But you say, wait a minute, where's the proton? Well, it's understood that we have a carbon in this area, and it's also understood that this carbon is bonded to 3 other hydrogens. So Our problem has been solved. And these electrons will be forming a bond with one of these hydrogens. It could be any one. It could be this one, or this one. And these electrons forming a bond between this hydrogen and this carbon will be moving back to the carbon, giving it a negative charge in the products. And our products will be the following. This hydrogen is bonded to this nitrogen because of the mechanism that occurred here. Okay, now the next step is to identify our conjugate base and our conjugate acid. And in this case, this acid produced this conjugate base, and this base produced this conjugate acid.